All right. Hello, everyone. So in this video, we are going to be discussing about the implementation of Vigenere Cipher. In our previous videos, in our previous lecture discussions, we have already discussed the logic behind the operations of Vigenere Cipher's encryption and decryption. Okay. So in this video, we are going to be specifically focusing on the implementation part of how we can implement Vigenere Cipher, and we are going to do it using the Python language. So the key thing to remember about Vigenere Cipher is that we have a different key to encrypt every letter in the plain text message that we are trying to encrypt, and then perform the reverse operations when we are trying to perform decryption. Okay. So here, the example that we are going to take is that if we have a very simple plain text message, such as attack at dawn, which has a total characters of 12, and then we want to encrypt that using a key, which let's say is lemon, having a total character of 5, then how we are going to perform or implement this encryption operation and the decryption operation using Vigenere Cipher, right? So this video is designed for students specifically who are new to programming. So they don't have very strong programming backgrounds, or they have fundamental programming background where they know how to perform some of the basic programming constructs in one of the programming language. So first, we are going to discuss some of the key things that we need in order to perform the different programming operations and how to implement that using Python. And then we will go over the code of how to implement the cipher itself, the encryption process and the decryption process. And I will explain what each sentence of the implementation or each line of code in the implementation essentially does. All right. So first of all, in order to perform the encryption and decryption in Vigenere Cipher, we would write it as two different functions. Okay. So if to give a quick overview of what a function does in a programming construct is that you can write a specific set of code or specific lines of code, right? And you can wrap that inside or under a label, which we call as the function name, right? And anytime we want to call or implement these lines of code, right? All we have to do is call that particular function, and then whatever those lines of code are, it will get executed again and again, right? So for example, if we want to perform, let's say, the logic of arithmetic addition, right? We want to add two numbers. So typically what we do is anytime we want to add two numbers, right? We would have to call upon the code which can perform the addition of two numbers. So let's say, let's improve the example a little bit more, is that let's say you have to add two numbers and then subtract the result from one of the operands of the addition. Okay. So that means, let's say if you have two numbers which can be represented as a comma b, then first operation that you have to do is perform the addition of a comma b, and this will give you the result of c. And then you will have to take that c, and let's say you have to subtract that from a, or add or subtract it from a separate number, let's say d, and that will give you the final output. Okay? Something along these lines. So here you can see that there are two lines of code, which is to first perform the addition and then take the temporary output and then subtract it to another input. Let's say this is given by the user, and that will result in an output. So this is like two lines of code, which is implementing some sort of a logic that needs to be repeated every time you want to essentially implement this logic. So what we can do is, instead of, let's say, we want to use this operation 5 different times, right? We want to carry out these operations a net total of 5 times. So if we write these lines of code again and again, okay, so that means we would have to essentially implement these 2 lines of code a net total of 10 times. And that will increase the redundancy in our code base, because every time we want to execute these 2 lines of operations, we only should be, in an ideal situation, passing in the different input values of A, B, and D. So let's say for the first time, A has a value of 10, B has a value of 5, and then D has a value of 7, right? And maybe in the next execution, the second time that you want to call this particular lines of code and do these 2 sets of operation that you see on line 10 and 11, then you will pass in the new values of A and B. So let's say you have A as 11, B as 15, and D as 25, something along these lines, right? So essentially the operation doesn't change. That is, we don't change the idea that we still use A plus B and then we use C minus D, but we never change. And the only thing that does change is basically the values that are passed to these variables. So instead of writing these lines of code, repeating these 10 times, what we can do is we can write the logic of the code that we want to execute only once, which will be just these 2 lines of code. And then we can wrap this under a label, right? And let's say we can call it some sort of a arithmetic operation, right? And we can declare that as a function. And within that function, we can wrap these 2 lines of code. And then anytime that we would want to use these 2 lines of code, right? All we do is call the name of the function. That's what we call it, as executing the function. And then within these first brackets are indicative of the fact that this label is basically the name of a function. And then within these first brackets, we can provide the input parameters. That's the technical term we use when we are passing values to a function. And we can essentially write those input parameters like this. And then whenever we need to call this function, we will write down the name of the function again. Okay. And then inside of that, we will pass in the actual values, let's say 10, 5, and 7, right? So then these variables, A, B, and D, will store these values. It will perform these operations. And then once the operation has been performed, then the final output of this function has to be returned, so to speak, back to wherever that function was called. So what we do at the end of the function body, once all the operations are done, if this function is supposed to give the user or give us back any kind of output, then we use a keyword called, a syntax called return statement, which is given by this return keyword. And then we write down whatever this function is trying to return, which in the case of this example is the final output that is generated by the function body. So the location or the pointer in your code where you're calling this particular function, you need to have an output variable that will be able to store the value that is returned by the function body itself. Okay, so that is the reason why we would want to design the implementation of most of the programs that we write in a modular way, right? By using functional paradigm, such that any type of logic that is repeated multiple times, we can encapsulate that inside a function. And then whenever we want to use the logic of that code, which is encapsulated within that function name, we call it, and the individual times that we call it, we just change the input parameters that we need to pass to the function so that the function can generate the unique values every time by processing the set of inputs based on the logic that is specified or implemented within the function body. Okay, so if we want to implement this in Python, essentially what we do is we use the function keyword, right? We use the def keyword, and then we provide the function name. So the function name would be anything that you want to do. So let's say for our ongoing example, we said we want to perform some sort of a arithmetic operation. So we will give this name of arithmetic operation, and then we will have the first brackets, okay, the first parenthesis, which will indicate that this name is a function name. And then we will have a colon at the end. And then if we go to the next line, we can define some logic. So let's say here, we will say, write your logic for the function body. Okay. And then after all the logic is done, we will simply put a return statement. And then within these first brackets, we can write our input parameters. So I can say if this function takes 3 input parameters, so I will say parameter 1, comma, parameter 2, comma, parameter 3. Okay? And let's say this returns some sort of an output variable, and we can declare that output variable here. And let's say this output variable is going to be some plain integer value. So I will give it a default value of, let's say, 0 to begin with. Okay. And then you can write whatever logic you have that you want to implement using this function. You can just put it down here. And after that logic has performed its operation, it will return the output variable. So this is what we call as declaring a function. Okay. And then there is another component to using a function, which is basically to invoke or execute a function. So whenever you want to execute a function, if that function returns a value, so you will create a variable that will be able to store that value that is being returned by the function, which is done by this particular line. And that will be assigned to a call or an invocation of the function, which is done by using the name of the function itself. Okay. And then inside of that, you can pass in the different parameters like we discussed, and that will essentially perform all your operations. Okay. So the benefit of this is basically reusability. If you need to call these lines of code multiple times, then just writing it once under a function body, inside a function body, and then just calling the function makes it much more easier in order to design our program. Okay, so having said that, we have to identify in the implementation of Vigenere Cipher, what are the different sub-logics that we are going to implement again and again. So the two logics that is, of course, that is going to be executed again and again will be one in the form of, let's say, an encryption function. Okay. And then one will be in the form of a decryption function. All right. So, and in addition to this, both of these functions, we need to write these functions down. So let's say we create a rough template of the definition of these two functions. Let's declare these two functions and let's leave the body out for the time being. So we are going to say we want to define a function which will do encrypt Vigenares. So we'll just leave it at encrypt Vigenere. Okay. And then this will take in some input, and we will come to that input in a short moment. Let's just define, and I will just keep an empty return statement because we don't know for now, essentially, what do we want to return from this message. So we will get back to modifying this function definition in a short while. And then we want something along the lines of decrypt Vigenere. Okay. And then we will put a return statement here in order to make sure that this is able to decrypt. So I have a typo here. It should be def. Okay. All right. So these are the two main functions that we will have. Also, with respect to the logic of performing Vigenere's function or Vigenere's encryption, we had discussed previously when we were discussing the logic of Vigenere function that if the size of the key is not equal to the size of the message, then we will have to extend that key to the same length as that of the message. So what I mean by that is that this example message that we are dealing with here, or that we have taken as an example, has a total of 12 characters. And the key that we have hypothetically chosen to encrypt this particular message, it has a total count of 5 characters. So the logic of Vigenere cipher dictates that we have to increase the size of the key to the size of the message itself. So that means if this is our message, we write it down again. And then if this is our key, and we write that down in the next line so that it is one by one, then now we have to extend from characters 6 till we reach to character 12 by repeating this key, okay, in a cyclic fashion such that it extends to the entirety of the size of the message. So that means I'm going to write here by repeating the key LEMON, and then I'm still not done. I still have 2 more characters left. So I repeat the key again, and then I stop when I have reached the total characters of the plain text message. So this will be the final key, okay, or the modified key that will essentially be used in order to perform the character-wise encryption for the plain text message in order to generate the ciphertext message. So this process where we checked if the total characters of our plain text message is equal to the total characters of our key, our secret key. If it is the same, so that means if originally our message was 12 characters and our key was also 12 characters, then we wouldn't have to perform this operation that we just discussed. However, if they are not of the same total character count, then we would have to repeat the key, one character of it at a time, starting from the beginning, such that we can increase the length of the key to the length of the message itself. So again, this is a processing which will be performed multiple times, depending on the nature of the message, right? So that means in the first execution of, let's say, this script, we have this message in this key. In the next execution, we might have something different. Or if we are given multiple messages that we need to encrypt, then we will have to perform this modification operation of the key multiple times again, right? So in a situation like that, it would be beneficial if we can just define a function which will encapsulate the logic of how this key needs to be increased in its size such that it is of the same length as that of the plain text message itself, right? So the third function, or not, let's say the third function, we will call it the 0th function, because this is like a pre-processing step which needs to be performed before these 2 operations can be done. So based on the order, we need a function which will be able to generate the key. Okay, so here we will define the rough outline of our key generation. So we will say generate Vigenere key. Okay, this is what we will name the function. We will give the first brackets again to indicate that this is a function name. We will give the colon, that is the Python syntax. We will go to the next line and we will leave an empty return statement for now. Okay. Now, we have the outline of the 3 major functions that will make up the implementation of our overall program. So the next thing that we have to figure out is, to finish this function definition, the first thing that we have to ask is that what will be the input to this key generation function? What will be the input parameters to this encryption function? And what will be the key parameters or the input parameters to the decryption function? Okay, so let's start with the encryption function itself. The encryption function is going to take 2 inputs, and that is quite plain and simple in front of us. And any encryption function more or less takes those 2 major inputs. The first one is going to be the plain text. So let us call that as whatever message the user is providing us. So we can represent that using a variable name called MSG. You can name this whatever you want. You can call this plain text. You can call this with any other name, user input, whatever it is, as long as it makes sense, right? So let us call this plain text here. Okay. So it makes a little bit more semantical sense with respect to the input. And the second input that we are going to be providing to the encryption function is basically the secret key. So we will separate multiple input parameters using a comma inside of the first brackets. And here we will just simply write secret underscore key. Okay. So these are the two inputs that will be provided. Now, again, if we want to modify the key, if we want to check first if the size of the key is same as the plain text message, and then perform whatever operation we need to perform in order to generate the rest of the key to make it the same size, then the input parameters are again going to be the plain text and the secret key. Because first we need to compare both of them and then we need to modify the secret key. Okay. So those are the two operations that we are going to be performing. And then at the end of this function, we will be returning the modified secret key. Okay, so the modified secret key will be of the same length compared to the plain text. All right, so that is why I've written the secret key here itself. Now, as far as the encryption output is concerned, we have to create a new variable here that will essentially store the cipher text. Okay, so here what we can write is we will say that there is this new variable and we will declare this new variable as a list. Okay, so the reason why we want to declare this as a list, because that allows us to store all these messages in a single unit, but treat these individual characters as its own entity. So what I mean by that is that if I store this particular plain text message inside a list, okay, so we have 12 characters here. So let's say I create something like let's do this. Let's say I create plain text, and that's a list. Okay, and to this list, I'm going to dump all of these values one by one, right? So in order to do that, I will simply have to separate those values with a comma, and then I will have to write it down. Okay, so the benefit of doing this is that now if I want to just process the first character of this entire message, then all I need to do is write plain text 0, okay, and that will give as output this particular letter and not the next letter. So next, if I want to go to the next character of this message, I will change the index of this value, the value within these third brackets, and the third brackets indicate that this name here is a list and not a plain variable or a function. And this will return me whatever the second value is within that particular list, right? So this allows us to like individually select each of the characters and then perform whatever encryption operation that we need to perform on top of them, right? So this makes the processing part a little bit more easier to work with. Okay, so once we do that, essentially we can generalize this process by saying that if we have a list, right? So let's write this statement down, that if we have a list of size, let's say for this example only 12, right? So this is basically, we can call this as either the length or the size of the list. Okay, then the first index of the list is 0 and last index is n minus 1, where n is equals to the size or the length of the list, which in this example, that is 12. So this will give us essentially the value of 11, right? So anytime we want to go over, or the word that we use technically is traverse the list. So that means we are going from travel from the first to last index, one index at a time. So this is the operation that we want to do. We want to traverse the list. We want to start with the 0th index and go to 1, 2, 3, 4 until we reach n minus 1, right? So this operation is a repetitive operation, right? We are repeating the process of visiting the first index, then visiting the second index, and then every time we visit these indexes, we would want to perform some kind of processing, right? And that some kind of processing in this particular case would be, we take the first character, we look at whatever the key is, we perform the encryption and generate the encrypted character for the first index. Then we go to the next index, repeat the same process and keep doing this until we have covered the entirety of our input plain text, right? So this process we are repeating. So generally, when we try to implement some sort of a repeating action, right? If we are repeating or we are looping over, let's say, a list, then we implement that using what we call as for loops. Okay. So for for loops, you essentially have to keep in mind that there are three different things. Okay. So when we are declaring a for loop, we have to say what is the start, what is the end. Okay. And then inside of the body of the for loop, we have to specify what logic do we want to execute on each repeat, on each loop iteration. Okay. Let's call this loop iteration. Okay. So this will allow us to perform the same operation again and again. And the for loop will essentially keep a track of traversing from the first index to the last index of the list. So that is why we are storing this as a list, both this, and then we will operate on the plain text as a list as well. So that will allow us to kind of traverse over the message and then take one character at a time and then perform the encryption operation on top of that and then store it back. Since we're doing it one character at a time, we can store it back to another list, which will be treated as our ciphertext, right? So this is basically the entity that will be returned by our function. Okay. Now the same operation or the same structure of input and output will be applied to the decryption operation, because remember, the decryption operation will also take not the plain text this time, it will take the encrypted text. So here we can call it as ciphertext instead of calling it plain text. It will still need the secret key in order to perform the decryption. And then we can call this the decrypted text, decrypted text. Okay. Just like we have the encrypted text in line 24, but that was for encryption. And then we will take this guy and we will return that. Okay. So now we essentially have the more or less the logic, the structure, the outline of what our implementation is going to look like. So what we need to do now is start filling out the actual logic of each of these functions. We have now defined our functions. We have defined what input parameters will be taken by the function. We have defined what output will be returned by the function when it is implemented. And let us put a comment here. Okay. So comments are basically lines of code which are not included in the actual execution. So we include these comments essentially to improve the readability and the explainability of the code that we are writing. So in Python, we can write a single line comment by using this hash symbol. If we want to write a multi-line comment, then we can give these 3 single quotes or double quotes, and then we can write a multi-line comment as we have been doing up here. So essentially, everything that you see in this different color, what this essentially means is that all of this will not be treated as Python code. They will not be undergoing any kind of syntax check or any mistakes that you have made in your writing or in your syntax of your code. So these are just there to explain things in the code itself and so on and so forth. Okay. So here we will, one extra comment that we will write is to implement or call the functions above. right? So later on, we have to make sure that we call these functions as well. So let us bring our focus to this first function here, which is to generate the key itself. So once we receive the secret key here, what we are going to be doing is we will convert that secret key to a list. Okay. So first we will use the inbuilt function for list and pass to it the input parameter that has been received. Okay. So this will convert. So for now, when this input is received, this is basically a string. That is one of the data types that we use in a function. Not in a function, but in different coding languages. And then we are converting that to a list by calling this input, this inbuilt function in Python, which essentially converts the string into a list. So now we can individually access each of these characters by saying list 0 will return, let's say, L, list 1 will return E, and so on and so forth. Okay, so that is why the first step is to perform these operations. Now, whenever you look at a code like this, whenever you look at a line of code like this, you would want to read from the right and then go to the left. So the way I would translate this line of code is that you take the input parameter, which is secret key, whatever value it is inside of this, pass it as an input parameter to an inbuilt function called list, and then whatever output is generated, you store that back to the original variable, which is secret key, but now it is a list, okay? And it will overwrite whatever original content there was in this particular secret key thing, right? So this is basically a type conversion that we have done here, all right? So the reason why we want to do the read of the operations from right to left is that this is the assignment operator. So the assignment operator, based on the order of execution of operations, will first execute whatever you have to the right. And then once the operation has finished executing, the result of that execution will be assigned, which is what this operator is, to whatever you have specified on the left. Okay. So that is the reason why whenever you're looking at a code and you have the assignment operator, first pay attention to what is happening to the right-hand side. Make sure that you understand all the processing and everything. And then whatever the resulting output is, that is assigned to whatever you have on the left-hand side. So that is what we're doing. Now, what is the logic? The next step that we have to do. So let's say initially here we received the message that the secret key lemon, and we received this plain text message, attack it down. Okay. So now the first thing that we have to check is if the length of the plain text message is the same as that of the length of the secret key that we have received within this function body. So let us go ahead and do that. And remember, the next thing that we have to learn is in coding, whenever we want to implement the logic of decision making. Okay. So here the decision making is if length of key is same as length of message. Or if you want to think of any other example and say if age is X, then do something else. If age is greater than X, do something else. Otherwise, some other case. Right? So this is basically the idea of decision making, that based on the outcome of evaluating a certain logical condition, and that logical condition could be checking for equality, right? So that means you can check if the two values are the same. So then you will use this operator that we call as equality. You can check if it is greater than, you can check if it is less than, you can check if it is greater than equal to, or less than equal to, or not equals to, right? So there are many different logical operators that are out there. arithmetic and logical operators that you can use in order to kind of understand whether the outcome of a decision is true or false, right? And since you're checking a decision, right, since you're checking a condition that is logical, the output is going to be always true or false. Okay. Now, depending on whether the output of whatever you're evaluating, so let's say if age is greater than X, or if age is equal to X, right? Or here, if length of the key is same as length of the message, or this one we can say is equal to length of the message, right? So these are all logical conditional checks. And as a result of that, that check will either return a true value or it will say, no, it is false. And based on whether it is true, you will code certain lines of code. Okay, you will implement certain lines of code, which will be executed only if the condition is true. Or you will specify the alternative to it as to what your code needs to do if the condition is not true, right? Which is basically meaning false. Now, the way we implement that in programming is using this construct called if-else statements, right? And the typical structure of if-else statements is you have a syntax keyword called if, and then you have a condition. So this is also a condition. So you can think of it like this is a check that will happen within the if statement. So you will write down here condition 1. If condition 1 is true, then you will write logic for true part. Okay. And then if has an else part to it. So that means if this condition is false, then what do you need to do? Right? So here you can just say logic for false part. And this is with the expectation that you don't have to check anything else. So if you notice here, when we wrote the second example, we checked two things. First, if age is X, then if age is greater than X, if none of these two conditions were true, then we have some sort of a default case, which is what we have written. So that means if you want to chain a bunch of decision-making statements together before you execute a default false case, then we call that as an if-else-if statement. Okay, so the alternative or a variant of this is if-else-if statements. Okay, and the way we write this is after this, we do else if condition 2. So this will be the second condition here that we are checking. Then we write logic for second true part. Else we write the otherwise logic here. That means if none of these previous cases are true, then you are going to execute the else part here, the default part here, right? So that is basically the idea of if-else-if statements. So we are going to use a simple if-else statement here. We don't have to check multiple logics. We only have to check if the size or the total number of characters in the secret key is equal to the total number of characters that is present in this plain text document. So what we are going to do is we are going to use again the syntax for if, okay? And the syntax for if after that is the condition. So we are going to check the length of the message. So the length of the message can be checked by using this inbuilt function called len, okay? And it will return a count of the total characters that is present in the message. So here we will pass in as input the plain text, and then we will use the equality operator, which is the double equal sign. Okay, it will check if LHS equals RHS or not. So the RHS is going to be the length of the secret key, right? So we'll put that secret key down. So now, if this condition is true, what do we do? If both of the size of the plain text and the secret key are the same, then we don't need to do anything, right? Then the key is good. We can proceed with the encryption operations. No further adjustments are required. So we are simply going to, at that point of time, if this condition in line 35 is true, we are going to return the secret key. That's it. That's the end of this particular function body. However, if the conditional check of this equality operation on line 35 is not true. So that means we need to write, what will you do if we have the false condition? So that means we are simply going to say else. Okay, we are not checking any other condition here, so we don't need a else if part. So we are simply going to write, what do you do in the else? Now, all we need to do in the else part of the logic is we need to go over the range of the difference between these two. So for example, when we had lemon here, the difference of the characters between these two, that is how many extra characters do we need to generate? Well, the amount of extra characters that we need to generate here is the difference between the length of the original plain text and the length of the original secret key. And then for each of that difference, so that is a repeating action. So if we have a repeating actions, then we need to perform this for loop here, where the start will be the 0th index and the end will be the difference between 12 minus 5, which in this particular example, it will be 7, right? So we will repeat it 7 times, repeat the operation. And what operation do we want to repeat? We want to take the first character and then append it to the end of the secret key and then repeat the operation until we have completed the desired number of steps. So to implement that, here under the else part, we are first going to write a for loop. So we're going to use the keyword for, okay? And we need a loop control variable that is going to keep a track of the operations that will be performed in every iteration of the loop, right? So let's take that loop control variable as I, right? So if you want to know like what is the value of I, and let's say we are in the 3rd iteration, then that will refer to the 3rd character or 3rd number of repetition and stuff like that. So we need something that can keep a track of how many times we have repeated, okay? So that something is called the loop control variable, and we are declaring that as a variable I, okay, which is the typical standard of the conventions that we use in order to declare the variables. And now we are going to say for I in range, okay, of the length of the plain text message minus the length of the secret. All right. So this internal range function, what this does is it will take whatever the value is and it will iterate I from 0, that is the starting index, to whatever this value is minus 1. Okay. So it will go over that particular range. Now, this is the setup for the repetition. So that means we have only written this part here. We have specified what the start is. We don't need to specify the start since we are using this inbuilt function range. So it will always start from the first index that is kind of given. If that is not the case, that is, you want to start it from a different index, then this will probably not work. Then you will have to specify the starting index for I. And the end is specified by this particular function, the range of the difference between the size or the length of the plain text minus the length of the secret key itself. Okay. And the second thing that we need to write here now is what activities do we need to repeat as we perform all of the individual iterations of this for loop. So that means what we are setting this up for is that we're telling the program that, hey, from 0 to whatever this value is, as you visit each index, which is tracked by I, please perform or please repeat the following operations that we are going to be writing here, right? So here we will write those operations. And what do we need to do? We need to take the secret key and we need to append. So we are going to use another internal function that is given by Python, which is called append. Append is basically adding something to the end of something that already exists, right? And this is a function. So you will have the first opening and closing brackets. So what do we need to append to this? We essentially need to take the secret key. All right. And now remember, the secret key is a list, and lists are indicated by these 3rd brackets. We have declared in line 34, we have made a type conversion of this string to a list. So that is why we are using these third brackets here to extract or address each individual index in that particular list, right? And we are going to take I, which is the loop control variable, because that is keeping a track of which index we are currently in. And we are going to perform a modulo operation. Remember, modulo operation, which is indicated by this percentage sign, returns the remainder of the division operation. Okay. So that means if you do 11 modulo 3, then we will get 2 back from it. Okay, because the nearest one that we can do is 3 times 3, 9, and then the remainder essentially is plus 2 there. Okay, so that is what the modulo operation essentially does. It keeps it within a particular bounds. And we want to perform that modulo over the length of the secret key itself. Okay, so once that has been generated, we are going to return from this operation the final value, so which is written here. This is the thing that we want to return. We want to take an empty string. Remember, we don't want to return this as a list. We want to return this back as a string. So empty string is given by these double quotes. And to that, we are going to append a method which is called join. So join is going to take everything that this thing is generating in line 39, and it's going to join that to an empty string. So essentially the resultant is going to be a string itself. So the join is an internal function, and again, it needs an input, and the input is going to be this secret key. Okay, so that means every time everything that is being appended to the secret key, it is joined to an empty string, and then the string is returned out of this function. So again, based on a decision-making statement, this function can return two things: the same secret key if the length of the secret key is same as the plain text, or the modified secret key by checking what is the difference between the length of the total characters in plain text and length of the secret key, and then appending that secret key one at a time, okay, to that particular operation. So that takes care of our key generation. And this, whenever this is called, and we will call this inside the encryption function, it will perform the operations and give us back the modified secret. So let us now bring our attention to how the encryption needs to be performed. So in the encryption, we have already created this placeholder list, which is going to store the output of our encryption itself. So the very first operation that we have to do here is we have to check if the secret key is good to go. That means if the length of the secret key is the same as the plain text or any modifications are required. So what we are going to do here is we are going to call the function that we have written above, so which is this guy here. So we'll call this here in line 44. And this will take as input the plain text and the secret. Okay. And then this will return a value. We already saw that it will return either the value in line 36, or it will return the value, the appended value in line 40, right? So we will store that back inside here by overwriting the secret key. Okay, we will just overwrite over the previous content of the secret key, whatever that value that is written. So it could be the same value depending on the check on line 35, or it could be the appended value if this check goes false. All right. Okay, so now we have the secret key, and then we can focus on writing the logic of the encryption. So in order to perform the encryption, we again have to perform a for loop, but this time the for loop will go over each character in the plain text message, and then as each character is visited, it will perform the encryption, generate the encrypted character, and then we will store that encrypted character one at a time inside this list that we have created. All right. So for this, again, if we have to repeat any actions, we have to use a for loop. So we will write a for loop, create a loop control variable that will keep a track of the activities. And this loop control variable will go from a range of 0 to the length of the message itself, right? So the message is essentially plain text here. So this will be given the plain text value that we have as an input, to the function itself. All right. Then okay, so now we have written the for loop here, and then within the body of the for loop, we are first going to generate each character, or we are going to store each character of the plain text. So let us say we put it inside a variable called character. And what are we going to put? We are going to take the plain text and we're going to typecast that to a list and provide it with the loop control variables value as it iterates over 0 to whatever the length of the plain text is -1. Okay, so that will be the total length of the message. Now, once we do receive the character, so that means here, as the loop progresses, the line or the value of character in 46, line 46, would be, let's say in the first iteration A, second T, then A, then C, then K, and so on and so forth until it reaches length -1, which is going to be N. So this is 0, and this is length -1, and this is all the values in between, right? So that is what the value of this guy is going to be as the for loop iterates, goes from 0 to N-1 itself. Now the question is what or how we are going to perform the encryption thereafter. Now, two things can happen. Again, two decision-making things we need to account for. The character, first of all, could be uppercase, like we have in the message up there, or it could be lowercase, or it could be a special character, like for example, dollar, pound, star, ampersand, or something along these lines. That is, it's not an alphabet in uppercase or lowercase. It's some numerical value or some special character within the message itself, right? So there are three alternatives of what this character could be. So we have to check, first of all, if the character is in uppercase. We have to check, secondly, if the character is in lowercase. Otherwise, if the character is not in uppercase or lowercase, then it means that it will be either a special character or some numerical value, right? So we will leave it as such in that particular case. So we have to write three if-else statements here. So that means we need an if-else construct. So the first if that we are going to be writing here is to check if character is upper. So there is an inbuilt function to essentially check that. So we are going to be calling on that function, right? And then we will do something here. So we will leave some random code here for the time being. Else if, so the syntax for that is elif, okay? And then we specify our second condition here, that is if the character is lower, and again there is an inbuilt function for that which gives us the output, and again this is going to return only true or false, okay? And we will leave some random lines of code here. Otherwise, if none of these is true, then we give the final default fail condition, that is if both the conditions or all the previous conditions have failed, then what do you need to do, right? So then you will do something here, which is to leave the character as such. So since we have to just leave the character as such, then we will just create an encrypted character as the final output. So this will be ENRCYP, encrypted character. And we will leave that as whatever the original character is, because we don't have to do anything about that, right? So we'll leave that as such. And then we will take all of these encrypted characters. So we'll use the same name to store the encrypted character here and here as well in lines 50 and in lines 48 operations. And once this whole for loop or this whole if-else statement is done, the chain of if-else statement is done, we will take our actual storage list, which is encrypted text, okay? And to that text, we will append, okay, the encrypted character that we have here. We will just dump it here, okay? So one by one, as each of these encrypted characters are generated, it will keep on appending it to the list. And then after that, we will return. So I think we had already written the return statement. Yeah, so we'll bring this final return statement, and to it, we will append an empty string. So we'll cast it back and we will use the join function, and we will take the list here and we will typecast it back to a string, and it will return whatever the overall output is. Okay. So now let's put encrypted character here and encrypted character here, because that will store the output of the individual character operations that will take place. Okay. So now how do we want to implement the actual encryption logic itself? Now, in order to do this, the logic that we will be following is that for each of the alphabets, whether that is lowercase or uppercase, there is an ASCII value range for the lowercase letters and for the uppercase letters. So that means there is a code, a numerical code to represent each alphabetical character, lower or uppercase, in the programming context or in the coding implementation context. So what I mean by that is that for all the letters, uppercase letters, going from A to Z, they have an ASCII code range of 65 to 90. So that means uppercase A is represented using the numerical value 65, and then uppercase Z is represented by the numerical value 90. Similarly, if you have lowercase a to lowercase z, then that is represented using the ASCII code of 97 to 122. Okay, so we are going to make use of this knowledge in order to perform the substitution. Remember, this is at the end of the day a form of a substitution cipher. And then we are going to apply some logic, algebraic logic, that is going to perform the operation. So I'm going to write down the algebraic logic first, and then I'm going to explain what we are essentially doing and why we are doing whatever we have specified. Okay, so the logic requires us to cast an alphabet into its corresponding ASCII value. So in order to, let's say, have the ASCII value of A as 65, what we can do is we can call an inbuilt function, an internal function called ORD, which is going to return, as you can see on the screen here, it returns the Unicode code point for a 1-character string. So that means if you pass in A to it, it will give you back 65, capital A, that is, right? Otherwise, it will give you 97 if it is small case. Okay. And then if you want to take any ASCII code, so let's say if you have 65 and you want to get A back from it, right? So what we do is we take char, which is again another inbuilt function, and we pass in 65 to it. And this is going to give us as output letter A. All right. So let us use these two internal functions in order to navigate between converting a letter to its ASCII and ASCII back to its letter. And remember, all of this has to be bounded within the total number of alphabets that we have in the English alphabet, which is 26 letters. Okay, that is another piece of information that you have to keep in mind that we are doing, right? So first, what we will do is we will perform the substitution first. Okay, so that means we will have to see what is the difference between, let's write it down here a little bit so we don't have to go back all the time. So let's say if the first character is A of the plain text and the first character is L of the ciphertext. So we essentially, sorry, not the ciphertext, but the secret key. We essentially have to find what is the whole difference between these two, such that we have to substitute by that particular amount for the new letter, right? So essentially what we want to do is, where does the character stand? Where does this character stand with respect to the beginning of the first letter A? And where does this character stand with respect to the beginning of the first letter B, A in this particular case, okay? So let me write that down to make it more meaningful. So the first thing we do is we take the ORD of our character. Remember, this character is coming from here, all right? And then we need to essentially subtract it and find how far it is from the beginning character of the alphabet, the uppercase alphabet. So that means the beginning character of the uppercase alphabet is essentially A, right? So this is what we are checking, is that we are checking the difference of where does this input character stands compared to the very first letter of the ASCII code, which is 65 in this particular case. Then we need to do the same thing, but for the first letter of the key. So that means we need to do ORD, and then we need to do the key, which is stored inside secret key, which is cast as a list here. So we will do I here. Okay. Remember, we have already stored the plain text in a different variable. So otherwise, if you do not create this variable, then you will have to replace every character with plain text I, just as we are doing it here for secret key I. If you want to take it another further step of simplification, just like we did for the plain text being stored in character, you can store the secret key I in a particular key, let's say variable key, and then replace that with key here if you want to simplify this further. Okay. So now we have done that, and then we have to do a minus ORD A. So this is to check where the two characters that we are dealing with, the plain text one and the character of the secret key, where does it stand with respect to its positioning, its ASCII code positioning, from the very first letter of the series, which is a capital A here. So now, if we combine these two, this whole operation together, right, then we can write ORD plus, and then we have this guy here. Okay, so I can cut it from here, and I can put it here. And then we have the minus, and this is being added twice, right? So ORD A, ORD A. So I can do 2 times ORD of A and then remove this extra addition. Okay, so this is the expression that we are getting to kind of normalize it within the ASCII series range of, for capital letters, I think we said between 65 to 90. So then whatever this value is, this differential value is, it will be normalized within 65 to 90. So that is what we are essentially achieving from this. Now, whatever this code is, okay, remember this will give us an ASCII code. So we will have to convert this back to a character. Okay, so before we do that, remember this value is ranging from 65 to 90. However, the English alphabet essentially ranges between 0 to 25, which is 26 in total. So we have to do a modulo operation here in order to normalize the ASCII range from 65 to 90 back within 0 to 25, and then convert it back to whatever the ASCII range is of the letter index within 0 to 25. Remember, this is finding what is the ASCII code of the letter that should be the resultant or output of the cipher text. And we are converting that letter range within 0 to 26. So it falls within the the English alphabet range. So we are doing a modulo 26. And then to find the ASCII code of that modulo range, we are adding the first letter back to it. Okay. And then this will be represented as a character itself. At the end of the day, this needs to be represented as a character. So in order to do that, we are going to call the inbuilt function called char, and that is going to provide us the input here. Okay. So again, first, to repeat this step, first, we are performing what is the substituted character in the ASCII range by taking the plain text character, comparing the plain text character and the secret key character against the very first starting value of the ASCII range, which in this case, if it is an uppercase letter, is going to be A. Once we find that particular code, right, then we do a modulo 26 to cast this ASCII code that we have received within this particular highlighted expression to the value between A to Z, capital A to Z. But To get the ASCII code of that letter, which we have received after performing this modulo 26, okay, we have to add back the ASCII range of the starting letter, which is again A, and that will give us whatever the actual ASCII value is of that particular resulting ciphertext letter. And once we receive that value, we take the entirety of this operation and then cast it back to the alphabet, which will be stored inside the encrypted character. Okay. So now, if we understand this, then we need to do this same operation, but replace the capital A's with the small letter A here in line 53. So we'll put this here and we will change this to A and we will change this to small a. And that's all we have to do. Okay. And then everything else is set up. So that kind of takes care of all the operations, and we'll remove this unnecessary comment. And this is what the encryption operation is going to look like. Okay. Now, to decrypt it, we have to reverse the operations that we have carried out here. All right. So in the decryption, we have created the decryption text here, and we have created the return statement. It's taking as input a ciphertext and a key. Okay. And then let's go ahead and start performing the same set of operations. So again, if the key that is provided to us, the secret key, it is not of the same size as that of the ciphertext, then we will have to increase that. So again, we will call the key modification function here. So we will copy this, we'll paste it here, and instead of the plain text, this time we will be sending whatever the ciphertext is. Okay. And that will return us the modified secret key. And then the operation is just the reverse of the operation of our encryption operation. So here we are going to copy the entirety of, well, let's type it out, okay, just so we can have some practice doing it again. So let's do a for loop, because we have to go character by character, create a loop control variable, which will go over the range of the length of our message, and our message is stored inside ciphertext. Okay. And what will it do as it goes over that message? First, let us store each of these ciphertext inside an individual variable just for ease of use. And that is being tracked by the loop control variable again. And once we have done that, we are going to again perform two different checks and one default condition. If the character is in uppercase, we have to do something. Okay. So if it is upper, remember this is going to give true or false. We do something. Else if we have the character is lower, then we do something. Else we have a default condition. That means both of the previous two conditions were not true. Then we are simply going to say that the decrypted character is equals to char. Okay, just like we did in the encrypted text, that the encrypted character is equals to char. And then we are just going to create the decrypted text here. So we will say decrypted text that we have generated, which is going to be the final return from this particular function. And we are going to append to it whatever our decrypted character is. We'll just put it here. And then finally, when we return this, we are going to create an empty string and join to it this decrypted text that we have created as a list, just like we did for the encrypted one as well. All right. So now we have to take care of the reverse operation for our decryption. So here in the decryption, this is our final output location for each character when it comes out of it, when it spits out of it. So now everything that we did, now we will do in a reverse way. So we have, instead of casting it on a ASCII range of whatever the character is, we have to cast it back to the 0 to 26 range, essentially. So what we want to do first is we want to take the ASCII of the character, okay, subtract it instead of adding it. So we don't want to move it forward. We have to substitute it back, right? So when we were substituting it, we were adding these two together to find what the resulting character is going to be. But when we are decrypting it, we have to move the shift backs, the substitution back to the original character. So we are going to be doing an ORD on the subtraction of the ORD on the key size. So the secret key, we take that, its index is being tracked by the loop control variable. All right. So that is what we subtract. And then we take these two, whatever the output of these two is, we are going to add to that the value of 26 to bring it back to the original character. And then we will normalize that within the A to Z range by doing a modulo 26, just like we did here. These operations are going to remain the same because all this is doing is once we get the actual ASCII value, we normalize it within 0 to 26 and then convert that back to whatever the ASCII range of the character is. So once we get this, we are just going to add to it whatever the first value of this range is, which is capital A in this particular case. And then we are going to set this up and find the final character value of this whole thing. Okay, so this will have to happen here. And let us check. We have made some error with respect to the brackets of opening and closing because this character value has to be received for the entirety of the operations. So let's see. So we need to take this, subtract it from the ORD. So then we will not have this bracket, I think. Okay, so we have the ORD character range, then we subtract it in order to find the reverse substitution. And once this reverse substitution is done, so at this point, we are going to add 26 to it, and then we are going to mod it using 26. Okay, so that looks correct at this point, hopefully. Okay, so ORD minus secret key plus 26 to cast in the range instead of doing twice for both. Yeah, this looks right. Okay, so that's basically the operation. And now we just, once we have figured out the operation for the lower value, the uppercase, we can just do it for the lower case by substituting it with a smaller a here. And this will remain as 26 because we are bringing it down back to the A to Z character range. Okay, so that's it. That's all the decryption that you will need in this particular operations. All right. So let's see what we have done. We have written a function for modifying the key. We have written a function for performing encryption, which checks two different cases, whether the character is uppercase or lowercase, or whether it is one of the appended special characters or numerical values. And then we reverse the process when we are decrypting the character, and we send the decryption value back. All right. So in order to create an example for use, we will create two different texts. So we can say, well, you can modify this code to take input from the user and make it a little bit more interactive. But for the sake of simplicity, I'm just creating two predefined input variables, and we are just going to say this will be user input equals to, and we can say, let's put it as a string, attack at dawn. Okay, and then we can give a key. So I'm just going to say user key in order to distinguish the fact that this is coming from the user. So we will say lemon, the example that we used. All right. So now we have to essentially call the encryption and decryption operations. So first, we are going to call our encryption operation here. So the name of the function is encrypt Vigenere. So I'll call that, and to it, I'll pass as input the first parameter, which is user input. We have to make sure that our mapping of the inputs are going to be the same. So for example, here, the first input parameter is the plain text. So I'm providing the plain text. And then the second input parameter is basically the key, which I'm providing as a second. Please remember, do not mix up the order of the input parameter, because that can throw your function off with respect to what logic you have specified. Now, this will return a value. So I'm going to store it inside, let's say, user output for encryption. Okay, so I'm going to store whatever this function is going to return in this particular thing. And then I need to print this message. So I will use a print function. So in Python, we use the inbuilt print function in order to function something. And in order to neatly organize it, we will use this F escape sequence. And we will say here that encrypted. So this is just for formatting, neat formatting of the output. So that's why we are using this F. So encrypted text is, and then we will give the value itself. So the value will be given as a call to this variable. So we put that within these curly brackets inside of these double strings, and that's it. And then what you can do is, if you want to decrypt it, you can provide the same information. Okay, so when I mean the same information, I mean you can copy this line of code. Let's copy both of it, and we can change the parameters of it. So we'll put it here, and we will say user output, and I made a spelling mistake here, encryption, and this will be user output encryption, encryption, encryption. Okay, so now here we will put, instead of encryption, we will put decryption, and we will put decryption here as well. And here, instead of user input, we will actually pass as input the encryption, just to double check we get the same value. Okay, so now we can essentially implement this and see if we can get the right value or not. All right, so let's try this out. So from my terminal, I am right now in the root directory where this file is. So I'm just simply going to say Python and then give the name of my file and then run it. Okay, so of course we have hit an error. So we need to address this error and see what mistakes we have made and take care of the operation. So we are being pointed from line 76. So this is the first error that has happened here, line 76 itself. And we are being sent back to decryption, I believe, or encryption itself, line 50. Line 50 here. All right, so we have made an error somewhere here. And this looks like the decryption, or is it the encryption itself? It is the encryption itself. Okay, so something is wrong with our encryption operation. It just says string object is not callable. Okay, so let us check what is wrong here. And step by step, we will address what is going wrong. So I will check on what the error is, and then I will address it in a short while. Okay, so give me one moment. All right, so after taking a look at this, I realized that I have made a typo here. So this is supposed to be a internal function which will take the ASCII code that is given here and it will return the alphabet for that particular ASCII code. Now, the name of the function is not character or char as I have written here. It is basically CHR, which you can see here returns a Unicode string for one of the character with ordinal I, where I is between these values that is given here, right? So we need to use this guy here, and I need to replace this everywhere that I'm trying to get a character back. So it will be these two lines of code. And then here as well, we need to change this and we need to change this. Okay, anywhere else? So we'll double check it again and see if the error appears. So let's clear this out and let's run this code again. Okay, so this works, but I have the same prompt here. I forgot to change. So this is decrypted text. And are we doing the same thing? Probably not. All right. So we need to address this logical error here. So I need to sit down and go over the logic one more time. We have made some sort of logical mistake because tentatively, when we encrypt the plain text, we should see after the decryption, we should see the original text back. So somewhere I have made a mistake with respect to the expressions that I have written. So let me just go ahead and double check that, and I will clarify what mistakes I have made again. Okay. Okay. So I think I found out where I made the mistake. So first what I did is I added a bunch of print statements at different checkpoints, which would allow me to kind of understand where the mistakes are. And the mistakes which I thought was either along the lines of the logic that we have written in these lines, or with respect to not using the ciphertext that was generated for encryption. Because if you noticed from the last errors that we had received, when we passed in the plain text and the secret key, we were getting the correct size of the secret key. So I know for sure, using these print statements that I have added, that my modified secret key is correct, which is of the same length and it is repeating itself. So there is nothing wrong with that. So I can kind of isolate the fact that, okay, nothing is wrong with this generate key function. Then I tried adding some print statements within the encryption function, and specifically the decryption function, because essentially we were not getting the plain text back once we pass in the ciphertext to this decrypt function. And then when I printed this, when I added these print statements, you can see here that I'm getting this modified key print statement, which I have written inside the encrypt function. So I know that if the program or the code runs inside this particular function, then it will print this particular printf statement that has been added here, right? However, when I added these print statements here, I noticed that essentially I was still getting the modified secret key for encryption, and then directly the decrypted text, the print statement for that is here. So that means I was calling this function. It was supposed to provide the decryption, but it was not executing any of the print statements, these debugging print statements, which I added in lines 62 and 63 in order to check if I'm using the correct value of the secret key for decryption and if I'm using the correct value of the ciphertext that is generated by the encrypt function. And while doing so, when I noticed that none of these print statements from within the decryption function was being generated, then essentially that indicates the fact that this function was not being executed to begin with. So upon further analysis, what I noticed that the mistake that I made was I called the same function for encryption in order to perform decryption, which is not logically correct. So I need to replace this with essentially a call to the actual name of the decryption function, which is decrypt Vigenere and not encrypt Vigenere. So we put that back here. And now if we come back down here, clear everything up, and if we run our script again, so we can get the decrypted text back. So this ensures that nothing is wrong with the logic of our function, which, well, we double check that with respect to the implementation. So the only mistake that was there is that I forgot to change the call to the decrypt function when I copied these two lines of code and then we implemented this. It was encrypting the encrypted text again, and as a result of that, we were getting some weird output for our decrypted text. which was essentially the mistake, right? So now you can change these messages. So let's say if from the capital letter, if I change it to attack at dawn, small letter, and we have to make sure that this is also small. Otherwise, it will create a problem with respect to the logic that we have written on how to deal with small letters versus how to deal with capital letters. So you can modify the code to double check if the secret key is not in the same uppercase or lowercase as that of the plain text user input message. Then you can essentially write a little bit of logic of changing that this code and make it more flexible so that the user doesn't have to bother about whether they provide the input key in capital letters or in small letter, or you can provide a restriction to the user input that if the plain text is in small letter, then the user key also will have to be in small letters and stuff like that. And that will ensure that the code performs correctly. Okay, so if we do that, we can see here, if we pass this, we get the correct key size, and it will generate a ciphertext in the small letter instead of the capital letter. And once we decrypt it, we get the original plain text back. Okay, so that is basically the logic of the implementation of Vigenere Cipher. All right, so one thing to note here is that when you do perform your assignments, of course, you will use this code that is provided here, and you will make sure that you are able to execute this code on your own local systems. I will share this code on GitHub, so you can directly access the code from GitHub itself. And then what you have to do for your assignments purpose is that you will need to document this code, and you will have to explain what each line of this code does on a summary, and then what is the purpose of each of these individual lines, what is the logic of encryption that we are performing, what is the logic of decryption that we are performing in your own words. Again, please do not use any kind of an automated tool or AI tool in order to do this, because the whole purpose of this is to assess your understanding of the implementation in your own words. So if there are any problems with respect to understanding what has been done, you can always discuss it with me, and I will help to better explain what the logic is, and submit that as your assignment, the documentation of the code as your assignment. And also I will create a separate portal where you can show that you have executed this code and that you are getting these outputs, right? So you can clean this code up a bit. You don't need all these printf statements that is written inside the functions that I have done. I have done this to double check and solve the errors that were being made. So this is basically a way of debugging your code to kind of isolate where the problem is, and then focus there. Because right now you can see I had 3 function calls. So I needed to put like printf statements at strategic locations where I know that, okay, I'm getting an output from this first function. So here, if I put a printf statement, and if this is correct logically based on what this function is supposed to do, then I know that there is no problem inside of this. And then I can move forward with this. And then the same thing I can do, because I knew that there was a problem with decryption. I added a few printf statements here in order to see if the problem was within this particular function, and that allowed me to isolate and understand the problem and catch the error that essentially I had made a typo with respect to the function that I'm calling, and I was not calling the right function. Okay, so more details will be given on how to prepare your assignments when the assignment will be uploaded on Moodle, so you can check that. And if you have any doubts, then you can always reach out to me and we can discuss it, right? Okay, so we will try this and I will take a feedback. So this is the first program out of the many programs that we are going to be doing for different aspects of cybersecurity fundamentals. So I will take some feedback from the class in the next, probably in the next 2 lectures, to see whether you like this way of having it done in a pre-recorded fashion and it being available to you when you do your assignments and you document the code and you explain it. And if there is anything else I can improve when making a demonstration for these codes, then I will take that as a feedback as well and try to continuously improve the delivery of the next set of programming assignments. Okay. So I look forward to hearing back from you guys regarding your feedback. And I hope you are able to complete this assignment and submit it within a week's time. Okay. So thank you. And we will talk more when we meet during the lecture classes.